In the previous videos, we have seen what is eigenvalues and eigenvectors and solved some numericals on finding out eigenvalues and eigenvectors. Now the topic is properties of eigenvalues and eigenvectors, or we can say some direct result on eigenvalues and eigenvectors. So there are some results which we can use, which you can remember, which are helpful in your exam, can be helpful in your exam. So the first result is trace of a matrix is always equals to sum of eigenvalues. So you can find out sum of eigenvalues by finding out trace of a matrix. Now the second result is determinant of A is equals to product of eigenvalues. So you can find out determinant of A by multiplying all the eigenvalues, or you can get product of eigenvalues by finding out determinant directly. Now the third point is, if one of the eigenvalues is 0, then the determinant of a matrix is 0. We know that determinant of a matrix is equals to product of eigenvalue, and if one of the eigenvalue is 0, then the product will be 0, hence the determinant will be 0. Now the fourth point is, eigenvalue of A and a transpose of a matrix A are same. Okay. Fifth point is, if lambda is an eigenvalue of A and determinant is not equals to 0, if these two properties are satisfied, if determinant of A is not equal to 0 and lambda is eigenvalue of a matrix A, then 1 by lambda is eigenvalue of matrix A ka inverse. 1 by lambda is eigenvalue of inverse of matrix A, and one more result can be find out using the value lambda is, if determinant of A is not equals to 0, then determinant of A divided by lambda is eigenvalue of adjoint A. Now the sixth result is, the eigenvalue of orthogonal matrix are always of magnitude 1. The sign may be 1, +1 or -1. The sign can be positive or negative, but the value will always be 1. Now the next point is, if a matrix is an upper triangular matrix, lower triangular matrix, or a diagonal matrix, then the eigenvalues are diagonal elements of the matrix. So if a matrix is given as 1 2 3 4 5 0 0 0 0, if a upper triangular matrix is given, then the eigenvalues are 1 4 and 0. So this is how you can directly find out eigenvalues of a upper triangular matrix, lower triangular matrix, or a diagonal matrix. So this point is very important, which can be useful to directly find out eigenvalues of such type of matrix. Now the next point is, eigenvalues of symmetric or Hermitian matrix are always real, and the next point is, eigenvalues of skew symmetrics or skew Hermitian matrix are 0 or purely imaginary. So these are some important points which you should remember, which can help you in exams like GATE, NET, or any competitive exam related to computer science or any stream of engineering.